Hi, these notes are optional. If you did not understand the classwork that we did on Tuesday, if you're period 3 or 5, or on Wednesday, if you're period 2 or 6, if you didn't understand the notes on substitution, then this is another opportunity to see substitution at work so that you can see how to do homework number 9. If you did understand the classwork that we did, you can skip these notes and you can go straight to class homework number 9. So it says solve each system by substitution. Solve for either x or y and then substitute that value into the other equation and solve. So see how this y is already solved for? It's y equals negative 6x minus 11. This is already solved for y. So we're going to take the negative 6x minus 11 and put it in wherever you see a y in the other equation. You solve into the other equation and you solve, and this time there only is going to be x's, so you're going to solve for x. So you write 8x plus 7, and then where you would put a y, you're going to put in parentheses negative 6x minus 11 equals negative 9, and now you solve for x. We're going to use the distributive property. Negative 6 times 7 is negative 42x. 7 times negative 11 is negative 77 equals negative 9. This is a negative, that's a positive. So you subtract and you get negative 34x. Add 77 to both sides. And we get 68. 77 minus 9 is 68. And then you divide by negative 34. We get x equals negative 2. But we want the system, so we want both equations. We want both variables, x and y. So you come back up to here, and y equals negative 6 times x. X is negative 2 minus 11. So it's 12 minus 11, which is 1. So you write it as a ordered pair. Negative 2, 1. And if we graphed both of these lines, they would intersect at that point, negative 2, 1, just like when we were solving by graphing. So the next one, it's already solved, y equals. So wherever there's an x, wherever there's a y, we're going to substitute in 5x minus 2. 5x minus 2. Use parentheses when you substitute, equals 2. Use the distributive property. Negative 2 times 5 is negative 10x. Negative 2 times negative 2 is positive 4 equals 2. 2x minus 10x is negative 2x. Subtract 4 from both sides. 2 minus 4 is negative 2. Divide by negative 2 so they cancel. And x equals 1. We come back up to the beginning. Y equals 5 times x, which we found out was 1, minus 2. So 5 minus 2 equals 3. So the ordered pair is 1, 3. And one thing you can do is you can take your solutions and you can check them. You can take put 3 in for x and you get 15 minus 2. Put x in 1. 5 minus 3, 2 is 3, and we get 3. Then you can substitute into here. 8 times 1 is 8, minus 2 times 3 is 6. 8 minus 6 is 2. Just to check, to make sure that when you substitute the values into both equations, they it works for both. Here's another one. Y equals, it doesn't always have to be y equals, it can be x equals if they give it to you that way. Wherever there's a y, we're going to substitute in 2x plus 6. So distribute negative 2x minus 12 equals negative 7. Two times 2 is 4. I multiplied wrong. So we get 0 minus 12 equals negative 7. Is negative 12 equal to negative 7? Never true. So we write no solution. The x's got canceled and we get an equation that's never true. So we write no solution. That means the lines are y if there's no solution and you graph them. They would be what? They would be parallel. That's why there's no solution. This one we have y equals negative 3x minus 9. So wherever there's a y, in parentheses we'll put negative 3x minus 9 equals 6. Distributive property 5 times negative 3 is negative 15x. 5 times negative 9 is negative 45 equals 6. Like terms, negative 17x, add 45 to both sides. 45 plus 6 is 51. Divide by negative 17. It might take you a while to figure it out, but x equals negative 3. Go back up to the top. Substitute it back in. Y equals negative 3 times negative 3 minus 9. Negative 3 times negative 3 is 9 minus 9, which is 0. Negative 3, 0. This one, none of the variables are solved for. So which one has a coefficient of a 1? 1x, right? So we're going to write 1x equals, we're going to subtract 8y from both sides. And now we can substitute this in everywhere where there's an x. We substituted negative 8y minus 5. So wherever there's an x, negative 8y minus 5. Get negative 16y minus 10 plus 16y equals 8. These cancel and you get negative 10 equals 8. Negative 10 is not equal to 8, so it's no solution. The lines are parallel. Which variable do you think we should solve for in this equation? In this system of equations, which one has a coefficient of 1? Y does. So we write y equals, move the negative 2x to the other side. And wherever there's a y, we're going to put negative 2x. Oh, when you move it over, you add 2x, this becomes positive 2x. So 8x equals 8x equals 1 if you divide by 8. And you put it back into here. 2 times 1 is 2. So the ordered pair is 1, 2. Try to remember that when you're solving a system of equations, it's a system. You get an ordered pair, you get a point where the two lines intersect. Unless they're parallel and they get no solution. So which one should we solve for here? This has a 1x. So 1x equals, subtract 4y. Wherever there's x, you put negative 4y plus 12. So we multiply and we get 12y minus 36 minus 12y equals negative 36. Negative 36 equals negative 36. Are these the same? Are they equal? Yes. It's always true. So we put infinitely many solutions. What happens is these are actually the same line but written in different forms. Like you could divide this one by a negative 3 everywhere and it would become that. So it's the same line once and then you graph it again and they intersect everywhere. So it's infinitely many solutions. Every single point is a solution on the line because it's just one line. So infinitely many solutions is the other special case. So you can go now and do homework number 9 and hopefully you'll be successful solving by substitution.